Hello students and good afternoon. So now I am doing class for class 12. So the topic is integration by the method of substitution. So in the last online class also we were continuing the same topic, that is integration by the method of substitution. Today also we will do the same topic. Same exercise 6A, 5 mark section, page number 351 from the book Higher Mathematics for class 12 by Sailendra. So now let's start this question number 5. So in the last online class we did up to question number 4. So now we'll start this question number 5. So now let us integrate this integral sign within square root x upon a minus x then dx. So how will you integrate it? So in this case also you have to do the trigonometric substitution. That is, I is equal to integral sign within square root x upon a minus x dx. Okay. Now in this case, what should you put for x? What will be the trigonometric substitution for x? You have to consider the expression in the denominator. That is, in the denominator there is a minus, only x is there. So what should you put for x so that you can use a formula in this case? So we have to put here x is equal to a sine square theta. So why are we substituting a sine square theta for x? Because if you put x is equal to a sine square theta, then a is taken common out here, and within bracket we have 1 minus sine square theta, which is equal to cos square theta. So I think you have understood it. So let us assume, let x is equal to a sine square theta. Okay, let x is equal to a sine square theta. Now let us differentiate it. So in case of integration by the method of substitution, if you substitute x is equal to a sine square theta, you have to differentiate both the sides with respect to theta. So differentiating both the sides with respect to theta. So therefore dx by d theta is equal to, now what is this differentiation? So a into sine square theta, it is just like your x square, 2 sine theta into again differentiate sine theta, that is your cos theta. Okay, let us do cross multiplication. Dx is equal to 2a sine theta cos theta d theta. So this is the value for dx. So I think you have understood it. Okay, now let us put it in I. So now what is I here? I is equal to integral sign within square root. Within square root, what is the value for x? It is a sine square theta. It is a sine square theta divided by, in the denominator, a minus a sine square theta into, and what is dx in this case? What is the value for dx? It is 2a sine theta, 2a sine theta cos theta d theta. It is 2a sine theta cos theta d theta. Okay. Now let us simplify it. Or I is equal to integration of within square root. Now in the denominator there is a common. If you take a common, it will be a within bracket 1 minus sine square theta, and here a will be cancelled, right? So it is sine square theta divided by 1 minus sine square theta into 2a sine theta cos theta d theta. 2a sine theta cos theta d theta. Okay. So let us simplify it further. I is equal to integral sign within square root. It is sine square theta divided by, what is 1 minus sine square theta? It is cos square theta into, this is 2a sine theta cos theta d theta. So I hope you have understood it. So let us simplify it again. Don't write here tan theta, but you have to write here integral sine. It is sine theta by cos theta into 2a sine theta cos theta. It is d theta. So here you can cancel this cos theta, cancel them. Okay. So now only a constant is taken outside integral sign. So a, and this is sine theta into sine theta is sine square theta. We need 2 there. 2 is already there. So you have to write 2 sine square theta d theta. And you know that if there is sine square theta, you have to multiply and divide by 2. But already 2 is there. That is your 2 sine square theta. Now you have to use the formula from multiple angles in trigonometry. What is the formula for 2 sine square theta? It is I is equal to a integration of, what is the formula? 1 minus cos 2 theta. Then it is d theta. Is that understood? Now we can separate the term. Or I is equal to a integral sine d theta plus and minus a integral sine, this is cos 2 theta d theta. Okay. Or I is equal to, this is your a into theta minus a into, what is integration of cos 2 theta d theta? That is, what is integration of cos mx dx, or differentiation of which function is cos mx dx. So it will be sine 2 theta divided by 2. Then you can write plus c. So I think you have understood it. So now you have to put the value for theta and you have to get the value for sine 2 theta also. So from here you can get the value for theta. If there is theta, you have to write it in terms of inverse circular function, right? So here, what is the value for sine square theta? X by a. What is the value for sine theta? It is root over x by a. So I'll write it here. What is the value for theta? It is sine inverse root over x upon a. Right? So from here we have sine square theta is equal to x by a. And what is sine theta? It is root over x by a. And what is theta is equal to, this sign becomes sine inverse root over x upon a. Is that clear? So let us put the value out here. Therefore I is equal to a. What is theta now? It is sine inverse root over x upon a. Okay. Then minus a by 2. Then we can write here the formula for sine 2 theta from multiple angles in trigonometry. What is the formula for sine 2 theta? It is 2 sine theta cos theta. Then we can write here plus c. So here you can cancel these two, cancel them. Or I is equal to, this is a sine inverse root over x by a minus a into, what is the value for sine theta? Sine theta is root over x by a. It is root over x by a into, what is cos theta in terms of sine? It is root over 1 minus sine square theta. So you express cos theta in terms of sine theta. That is your root over 1 minus sine square theta. So that we can put the value for sine square theta as x upon a. So let us simplify it further. I is equal to a sine inverse root over x by a minus a into, this is root over x upon root over a, right? Into root over 1 minus, what is sine square theta? Here sine square theta is x by a. You can write x by a here. Then we can write plus c. Let us simplify it. Or I is equal to a sine inverse root over x by a minus a into root over x upon root over a. Root over a is the LCM. So this is a minus x plus c. Understood? So next, or I is equal to a sine inverse root over x by a minus, here you can write a into, let us simplify it. So within square root here you may write x into a minus x divided by, this is both is root over a. What is root over a into root over a? That is your a. Then it is plus c. So here you can cancel this, a will be cancelled. Or what is I now? A sine inverse root over x by a. And what is the second term? Minus root over x into a minus x, then plus c. So this is the final answer. So I think you have understood the question. Okay, so you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 6. You have to evaluate this integral. That is given here is integral of x square dx divided by root under 1 minus x to the power 6. So how will you do this question now? So differentiation of which function may be x square? Differentiation of which function is x square? It is x cube, isn't it? What is the differentiation of x cube? 3x square. So you have to make this x to the power 6 as x cube whole square. So therefore I is equal to integral sine x square dx divided by root over, so this is 1 minus x cube whole square. And you know that the differentiation of x cube will be 3x square. 3 constant, but we are getting x square, isn't it? If you differentiate x cube. So let us assume, let z is equal to x cube. So now differentiating both the sides with respect to x. Okay. So therefore dz by dx is equal to 3x square, or dz is equal to 3x square dx. Is that clear? So now let us put the value out here, but before that get the value for x square dx. 3 is taken to the left hand side, dz by 3 is equal to, it is x square dx, right? So therefore it is I is equal to integral of, what is x square dx? It is dz by 3 divided by root over, this is your 1 minus z square, because here x cube is z, so it is z square. Okay. So therefore I is equal to, here 1/3 is constant, it is taken outside. Then integration of, it is dz divided by root over, it is 1 minus z square, right? So now within square root the power of z is 2. You cannot differentiate it directly. So in this case you have to do the method of substitution, that is trigonometric method of substitution. You have to do the trigonometric substitution method. Okay. So what should you put for z? It is, if it is 1 minus x square, you put x is equal to sine theta. But here it is 1 minus z square, so you should put z is equal to sine theta. So let z is equal to sine theta. Okay. So here you write differentiating both the sides, with respect to theta. So therefore dz by d theta is equal to, this is cos theta, or, so what is dz now? It is cos theta d theta. So therefore I is equal to 1/3 integration of, what is dz? it is cos theta d theta divided by within square root 1 minus what is z square? 1 minus this is your sine square theta. So what is the square root of 1 minus sine square theta? It is cos theta, right? So or I is equal to 1/3 integration of cos theta d theta divided by what is square root of 1 minus sine square theta? You know that it is cos theta. So let us put here cos theta. So this will be cancelled, or I is equal to 1/3 integration of d theta. Now what is integration d theta? If it is integration dx, you will write x. If it is integration of d theta, you will write theta. So therefore I is equal to 1/3 into theta plus c. But you should write down the answer in terms of x. So what is the value for theta now? So if there is only theta, you can put it in terms of inverse circular function. So theta is equal to, it is sine inverse z. So therefore I is equal to 1/3, it is sine inverse z plus c. Now what was the value for z? Z is x cube, or this is I is equal to 1/3 sine inverse, what is z here? Here z is x cube. Then what do we write? Plus c. So this is the final answer. So in this case, we can use different methods out here. You could have put here, since here z is equal to x cube, isn't it? Since here z is equal to x cube and z is equal to sine theta, directly in this case you can put x cube is equal to sine theta also. No need of doing all these things. Directly you can put x is equal to x cube is equal to, that is x cube is equal to z is equal to sine theta. Instead of that, we could have put x cube is equal to sine theta. That is the shortcut method. So यो problem तिमीले कसरी पनि गर्न सक्ने थियौ. X cube is equal to, directly you can put x cube is equal to sine theta. Okay, so I think I have understood it. So you can do it at home by putting x cube is equal to sine theta. So this is also correct method. The answer is 1/3 sine inverse x cube. So at home you can directly put, again you can do it at home by putting x cube is equal to sine theta. Is that clear to all of you? So again you revise it at home. Okay, now we'll do the next problem. So now we'll do this question number 7. You have to evaluate integral of tan 2x, tan 3x, tan 5x dx. So let us evaluate this integral. So first of all, you should write I is equal to integration of, this is tan 2x, tan 3x, this is tan 5x dx. Okay, but you cannot integrate it directly. Since this is the product, you cannot write separate integration, that is integration of tan 2x dx, integration of tan 3x dx, integration of tan 5x dx. You cannot write it. You cannot separate it is if it is product or quotient. You can separate the term if it is addition or subtraction. So you should convert this product into summation or subtraction. Then only you can separate this integral sign and dx. Since this is the product here, you cannot write integration for all these three terms. Okay, but in case of summation or subtraction, that is in case of addition or subtraction, you can separate the integral sign dx and then you can easily integrate them. But if it is product or quotient, you cannot separate this integral sign and dx. Okay, so let us convert this product into addition or subtraction. Is that clear? So how will you convert this product into summation or difference or subtraction? So you know that this is tan 5x, therefore tan 5x is equal to, can be written as tan 2x plus 3x, isn't it? That is, this 5x is written as 2x plus 3x. Or next, it is tan 5x is equal to, what is the formula on the right hand side? You can use the formula of tan of a plus b here. You have done it in class 11 in compound angle chapter. You have done this type of formula. What is tan of a plus b? What is tan of a plus b? Tan a plus tan b divided by 1 minus tan a tan b. 1 minus tan a tan b. So I think you have understood it. Okay. So it is tan of a plus b. Tan a plus tan b divided by 1 minus tan a tan b. Now let us cross multiply. Below tan 5x there is 1. Now cross multiply by 1 here. It is tan 2x plus tan 3x is equal to, now cross multiply by tan 5x here. Tan 5x minus, it is tan 5x tan 2x then tan 3x. Now we have to get the value for tan 2x, tan 3x, tan 5x. So let us take these tan 5x, tan 2x, tan 3x to the left hand side and all other terms to the right hand side. Okay. So now this becomes on the left hand side, it is tan 2x, tan 3x, tan 5x is equal to, it is tan 5. Let us take these two terms to the right hand side. So it becomes tan 5x minus tan 2x minus tan 3x. Is that understood now? So we have got the value for tan 5x, tan 2x, tan 3x. Tan 5x is equal to tan 5x minus tan 2x minus tan 3x. Is that clear? So instead of this product, we can use this addition or subtraction. Right? So therefore I is equal to integration of. So what is the value of this expression in terms of addition or subtraction? It is tan 5x. It is tan 5x minus tan 2x minus tan 3x bracket close dx. So this is the value for tan 2x, tan 3x, tan 5x as tan 5x minus tan 2x minus tan 3x. Then it is dx. Now you can separate. हामीले यो प्रोडक्ट मा चाहिँ हामीले इंटीग्रल साइन र dx सेपरेट गर्न सक्दैनौं. तर एडिसन और सब्ट्रैक्शन मा we can separate integral sign and dx. So let us separate the term here, then integrate. I is equal to integration of tan 5x dx minus integration of tan 2x dx. Okay, then minus integration of this is tan 3x dx. So I think you have understood it. So now you should know this formula, integration of tan mx dx. You should know it. What is the formula? Or I is equal to, the formula is, what is integration of tan mx dx? Log sec mx divided by m. Or you may write minus log within mod cos mx divided by m. So you can write here log within mod sec 5x divided by 5 minus, what is integration of tan 2x? It is log within mod sec 2x divided by 2. And what is the last one? Similarly, minus log within mod sec 3x divided by 3, then plus c. So this is the final answer. So I think you have understood it. So you can copy it. Now we will do the next question. So now we'll do the next question, that is 8 number 1. The question is integral sine x dx divided by sine of x plus alpha. So there is similar type of question, that is number 2. Number 2 will be a homework. We will do number 1. So this number 2 will be a homework, that is integral sine cos x dx divided by cos of x plus alpha. So instead of sine out there, it is cos, right? So we'll do number 1 here, and this number 2 will be our homework. So now let us write I is equal to integral of, this is sine x dx divided by sine of x plus alpha. So in this case we may use the method of substitution, that is you can assume x plus alpha as z, so that you can differentiate both the sides with respect to x and you can get the value for dx, and you have to put the value for x in the numerator. So there is another method. Without method of substitution also you can do this problem. So what is the method here? Since there is sine of x plus alpha is here, so here you can add x plus alpha, then subtract that alpha because there is no alpha in the numerator. Okay, so let us write here I is equal to integration of sine of, what is there in the denominator? It is x plus alpha. Let us write here x plus alpha within bracket. But is there alpha? No. So it is minus alpha. Then you can write dx whole divided by, you can write sine of x plus alpha. Is that clear? So now similarly you can do that number 2 also. So in this way we can do number 2. So number 2 is your homework, right? So now in this case this x plus alpha is taken as a and this alpha is taken as b. So from compound angle you know the formula of sine of a minus b, isn't it? What is sine of a minus b? Sine a cos b minus cos a sine b. Let us use this formula. Or I is equal to integration of, this is sine a. What is sine a? Sine of x plus alpha, sine a, cos b. What is cos b? Cos alpha. Then minus sign is there. Then cos a. What is cos a? Cos of x plus alpha into, what is sine b out here? It is sine alpha. So this whole divided by, you can write here sine of x plus alpha. Then what do we write? Dx. I think you have understood it. So let us close it within second bracket. Let us write down this fraction within second bracket. Or I is equal to integral sine within second bracket. Let us separate the term here. This first term divided by denominator, this sine of x plus alpha will be cancelled. You will have only cos alpha. Then minus, this sine alpha is constant, right? Sine alpha. And what's about cos of x plus alpha divided by sine of x plus alpha? This is your cot of x plus alpha. Second bracket closed. Then you can write dx. I hope you have understood it. Okay. So let us separate the term. Now, or I is equal to, now you know that this cos alpha is free from x. So it is a constant quantity. So you can separate the term here. Cos of y is constant. So it is taken outside. Integral sine dx. Then write down minus sign because there is minus here. Since sine alpha here is constant, it is taken outside. Integral sine. So it is sine alpha. Then integration of, it is cot of x plus alpha. It is cot of x plus alpha. Then what do we write? Then we write dx. Now we can use the formula. Or I is equal to cos alpha into, what is integral sine dx? That is your x. Minus sine alpha into, it is just like your integration of cot x. So x plus alpha can be taken as x. So what is integration of cot x dx? It is log of sine x. You know that, isn't it? So it is log of within mod sine x. But here what is sine x? It is x plus alpha. So which function is taken as x here? X plus alpha. Again you have to differentiate it. What is the differentiation of x plus alpha with respect to x? It is, for x it is 1, plus for alpha it is 0. So it is 1. So in case of integration, you have to divide it by 1. In case of differentiation, you have to multiply it by 1. But this is the case of integration, you have to divide it by 1. Since you have to divide it by 1, you don't have to write it. So this is the only integration, that is log within mod sine of x plus alpha. Then what do you write? Then we write plus c. So this is the final answer. So I think you have understood it. So you can copy it. Then similarly you can do this number 2 as homework. So this is your homework. Okay. So you can copy it. So now we'll do the next question. So now we'll do the next question, that is question number 2. So 9 number 2 is integral sine tan x minus tan alpha divided by tan x plus tan alpha dx. So this 9 number 1 will be a homework. Okay. So integration of sine of x minus alpha divided by sine of x plus alpha dx, that will be a homework. Let us do it first, 9 number 2. Okay. So let us integrate tan x minus tan alpha divided by tan x plus tan alpha dx. So here let us write I is equal to integration of tan x minus tan alpha divided by tan x plus tan alpha dx. So let us simplify it first. Let us convert it into sine and cos. Tan is sine by cos, isn't it? So it is sin x by cos x minus sin alpha by cos alpha divided by, in the denominator also you can write sin x by cos x plus, what is tan alpha? What is tan alpha? Tan alpha is sin alpha by cos alpha. So it is dx. Is that understood now? So now you can get the LCM in both the numerator as well as in the denominator. So in the numerator, what's the LCM? So here LCM is cos x cos alpha. You can divide this LCM by cos x. Cos x will be cancelled, so it is cos alpha. So it is sin x cos alpha minus cos alpha gets cancelled, so it is cos x sin alpha. Okay, so denominator was the LCM, here also cos x cos alpha. So here it will be sin x cos alpha plus cos x sin alpha. So you know how to simplify it, isn't it? So we have simplified this expression, so it is dx. So you can cancel this LCM. This LCM will be cancelled. Okay, so or now it is I is equal to, it is or I is equal to this integration. So or I is equal to, now this is integration of, now this is the formula from compound angle, isn't it? This is sin A cos B minus cos A sin B, right? Sin A cos B minus cos A sin B. Here A is x and B is alpha. What is the formula? Sin of x minus alpha. This is sin of x minus alpha divided by what? Sin A cos B plus cos A sin B. Here A is x and B is alpha. So what is the formula in this case? It is sin of x plus alpha. Then we can write dx. Okay. So we have got this expression. Now this question is same as 9 number 1, isn't it? So that's why this 9 number 1 will be a homework. Okay. So now we can use here the method that we have done in the previous problem. So whatever is there in the denominator, write it in the numerator. Since it is sin of x plus alpha, write sin of x plus alpha first, but you have to make it minus alpha, isn't it? So or I is equal to, since there is sin of x plus alpha, write sine of x plus alpha in the numerator as well. So it is x plus alpha. So we are getting x is correct, but here we have written plus alpha, but there is minus alpha. To make it minus alpha, what will you write here? Minus 2 alpha divided by, it is sine of x plus alpha. Then what do we write? Dx. So I think you have understood it. So now again you can use a formula in the numerator. X plus alpha is taken as A and 2 alpha is taken as B. So this is your sine of A minus B. Again you can use the formula from compound angle. What is the formula that you can use here? I is equal to integral sine, it is sine A, sine of x plus alpha. What is cos B? Cos 2 alpha. Then again minus sine cos A. What is cos A? Cos of x plus alpha into sine B. What is sine B? It is sine 2 alpha. This whole divided by sine of x plus alpha. Then we can write here dx. You can put this fraction within second bracket. Right? So now let us separate the term within second bracket. I is equal to integral sine within second bracket. This first term divided by denominator. Your sine of x plus alpha will be cancelled. You will get cos 2 alpha, then minus cos of x plus alpha sine 2 alpha divided by sine of x plus alpha. So this cos by sine will be cot, isn't it? Cos of x plus alpha divided by sine of x plus alpha will be cot of x plus alpha. So you first write sine 2 alpha into cot of x plus alpha. Then we can write here dx. Understood? So next you can separate the term, or I is equal to, this is cos 2 alpha is constant, that's why it is taken outside, integral sine dx minus, then which is constant here, sine 2 alpha integration of, this is cot of x plus alpha, then what do we write? Dx. Is that understood? So next, or I is equal to, this is cos 2 alpha into, what is integral sine dx? X minus sine 2 alpha into, now this is just like your, you can assume x plus alpha as x, so it is cot x. So what is integration of cot x? It is log of sine x. So here it is log of within mod, what is sine x here? It is sine of x plus alpha. Is that clear? Then what do we write? Plus c. Actually x plus alpha was taken as x, so it is cot x. What is the integration of cot x? It is log of sine x, but here x is x plus alpha. But again you have to differentiate the term which is assumed as x. Here x plus alpha is assumed as x. So what is this differentiation? Again you have to differentiate it. What is the differentiation of x plus alpha with respect to x? For x it is 1 and plus alpha it is 0. So it is 1. So in case of integration you have to divide it by 1. But since it is 1, dividing by 1, you don't have to write it. Okay? In case of differentiation you have to multiply by 1, but in case of integration you have to divide it by 1. But since it is 1, you don't have to divide it by 1. You don't have to write this 1. Okay? So this is log of sine of x plus alpha, then plus c. So what is the final answer now? So here x into cos 2 alpha, x is taken in the front, then minus, it is sine 2 alpha log of within mod, it is sine of x plus alpha. Okay, then what do we write? Plus c. So this is the final answer. So this question is also very important. So you can copy it. So this 9 number 1 will be your homework. Okay. So this much is for today. The next online class we will do more problems on this integration by the method of substitution. So this much is for today. So you can copy it.